In this video, I want to go through a sample proof to give you an example of how you use that toolkit of reasons in order to build proofs. One of the exciting things about geometry is that the things that we prove, sometimes, especially in homework and on tests, you might find yourself proving things that are just way out diagrams of lines and triangles and whatever. But there's also a very big category of stuff that is actually important. It's important that we use proofs to learn and convince ourselves about important facts about geometric figures and how they relate to each other. This is going to be an example of that. Pay attention to what we're learning and also pay attention to how we're proving it. All right. So what we have here is we've got this triangle. We're given that it's an isosceles triangle, which means that side AC is congruent to BC. And also, in addition to this triangle, we're given point D, which is the midpoint of AB. All right, so that point D and the line segment CD are going to be important to us for proving our case about this triangle. What we want to prove is that angle A is congruent to angle B. All right, so let me give you a sense of how I'm going to attack this proof. One thing to be clear about is that you already know all of the clues, both in this diagram and in the toolkit of reasons we've already talked about. So at any point in this video, if you want to pause the video and see if you can work forward, you should absolutely give that a shot because you might find yourself being successful at that. All right. So when I'm solving proofs, I like to work forwards and backwards at the same time. So let me show you what I mean by that. So I know that the final step of my proof is going to be proving that angle A is congruent to angle B. So I'm putting that down at the bottom of my page. I don't know what the reason for this is, but looking at the diagram and the information that we're given, we're not told anything about these angles. So what do I notice looking at this diagram that would be helpful to me? Well, I see that the diagram is made up of two triangles, and the way the diagram is written, it kind of looks like there's a reflectional symmetry between the left and right hand triangle. So what I might be able to do is to exploit that. So if the second to the last line of my proof, we're proving that triangle ADC is congruent to triangle BDC, then angle A would be congruent to angle B because of CPCTC. All right. So let's let me use my highlighter to indicate where these corresponding sides would be. So when I reflect from here to here, what sides line up with each other? So those two yellow sides would be corresponding sides. This pink side would correspond to that pink side there. And then the third side of both of them are blue. So if I could prove that those two triangles are congruent to each other, if I can find enough information to do that by one of my triangle congruence theorems, then I would have a complete proof. All right, so now that I've got this goal in mind, let me start working forward and think about the facts that I know. All right, so one fact that I know is I know that AC is congruent to BC. What's my reason for that? Well, that's given. That's given right here. Okay, another thing I know, all right, just a second. Let me take a second and I'll mark that congruence statement in the diagram. The other thing that's given is that D is the midpoint of AB. That is also given. All right, so what does it mean to say that D is the midpoint of AB? I need to turn that into a congruent statement. So if D is the midpoint of AB, what two things do I know are congruent because of that? Well, I know that D is the same distance from A as it is from B. That's what it means to be in the middle. So therefore, I know I can say that AD is congruent to BD. All right, and that is, do you remember the reason we gave for that? That is the definition of midpoint. I'm just taking the vocabulary word midpoint here, and I'm expressing what it means in geometric language. All right, so now that we've got that congruent statement, we can make that in the diagram. Okay, now the two congruent statements that we know are SSS and SAS. So we already have two sides in this. So if we can find another side or the angle between them, then we are all done with our proof, except for just filling in some details. Which one of those things can we prove based on the information we have in the diagram? We've used up all of our given statements, but we do know, looking at the diagram, that the blue side, CD, it's the same side in both of those proofs. So CD is congruent to CD. What's our reason for that? What's the name of the reason that something is congruent to itself? This is the reflexive property. Or to be more precise, it's the reflexive property of congruence, because it's congruence that's between the two things that are the reflections of each other. Okay, so now we've filled out the entire proof. We've got three congruent statements that justify this triangle congruent statement. The only thing that's blank here is the reason for that triangle congruent statement. So which triangle congruence theorem are we going to use in order to justify this statement? Well, since we've got all three sides here, this is SSS. Okay, so let's take a quick look at, now that our proof is totally filled out, we started out with one given side equal. We found another side equal because we were told about a midpoint. And so that took two steps of our proof. The third side of our triangles, we determined by the reflexive property. So because we know three sides, we were able to determine that these two triangles are congruent to each other by SSS. And because of that, because these two triangles are congruent to each other, the place where the yellow side meets the pink side in this triangle has got to be congruent to where the yellow side meets the pink side in the other triangle. And that's because the corresponding parts of congruent triangles are congruent. And so angle A is congruent to angle B. And that's the end of our proof. I want to give you one extra fact, just kind of looking at this. And this is not a super important vocabulary word, but it's one you'll hear me use throughout the year. This line, CD, was not really part of what we needed to talk about. So we were given this isosceles triangle. This is going to be true of any isosceles triangle. So if I've got a triangle with those two sides being congruent to each other, I can conclude that the two base angles are also congruent to each other. This extra line that was in that proof is called an auxiliary line. And you've maybe not heard the word auxiliary quite like that before, but you have been exposed to the concept. If you've ever plugged something into the back of your TV and you saw what was called an aux input, AUX, aux is short for auxiliary. So auxiliary just means that there's something that works, but an auxiliary thing is something that you can use alongside that thing so that it does something extra or something better. Like you can plug a game console into your TV through the aux cable. And just like that, in this diagram, we were able to prove something about an arbitrary isosceles triangle by adding in the midpoint of the base there. So let's go back and look at this important idea here, that when you've got an isosceles triangle with two congruent sides, these two angles, the angles that are on the opposite corners from those congruent sides, we call those the base angles of an isosceles triangle. They are also congruent to each other. This is going to be something that we use, maybe not this week or next week, but we will get there, to prove we're going to start actually using numbers to solve problems in geometry class, now that we've established some true facts like this fact we just learned about isosceles triangles. We're going to be doing other things like that. But the main thing I hope you took out of the video from this week's perspective is understanding how you can prove something, both working forwards from the things that were given and working backwards from looking at the diagram and the thing that we need to prove. And between those two, you can meet in the middle and build an entire proof using the tools that we've used up to this point.